party since long before that fatal day in 1912, when it disappeared beneath the waves. Its construction, representing the cutting edge of the time, generated the media buzz and promoted the notion that the ship was unsinkable. We are now going to talk about the iconic vessel that came to a tragic end. Just how much do you know about this world-famous ship? Well, it's time to find out.
Commissioned by the British shipping company White Star Line, the Titanic was created to satiate demand for luxury travel between Europe and North America. The ship's construction began in March 1909 in Belfast, Ireland. By the time it was sent to England for provisions, Titanic was one of the largest ships of its time. It was about 92 feet wide and 882.5 feet long, the length of nearly 3 football fields. With a height of about 175 feet, the ship above water was taller than most buildings. The Titanic also included new safety features, such as 16 compartments designed to prevent the hull from flooding. This caused many to believe that the ship was unsinkable. Such confidence led to the unfortunate decision to cut the number of lifeboats on board in half, in order to make the deck look clean and elegant. On April 10, 1912, Titanic left port in Southampton, England, and embarked on its first and last voyage. It first stopped over in France and Ireland, and by the time it set out on a long stretch of sea toward New York City, it had about 2,200 people on board. Unbeknownst to all, misfortune would arise just a few days into their voyage. On April 14 at approximately 9:40 and 10:55 p.m., warnings were sent to the Titanic's radio operators of ice fields, but they were never relayed to the bridge. At about 11:40 p.m., nearly 500 miles off the coast of Newfoundland, Canada, lookout crew on the Titanic spotted an iceberg in the ship's path and sent word to the bridge, but it was too late. The iceberg grazed the right side of the ship, causing its compartments originally deemed watertight to fill with water. Titanic's radio operators began sending out distress signals. At 12:20 a.m., one signal reached the ship Carpathia, which began making its way to the Titanic at maximum speed. Around the same time, crew began loading women and children into the few lifeboats on board. In addition to the shortage of lifeboats, some of the ones used were not being full to capacity, stranding even more people on the sinking ship. For the next 2 hours, the front compartments of the Titanic filled with water, causing the bow to sink and the stern to rise out of the water. At around 2:18 a.m., the ship snapped in two. The bow sank first, followed by the stern a couple minutes later. Those who went down with the ship were left in the freezing waters. Over an hour later, at about 3:30 a.m., the Carpathia arrived to pick up passengers. Of the 2,200 people on the Titanic, only 705 survived. Soon after the disaster, both the United States and Great Britain conducted investigations and developed new safety measures for ships. They required ships to maintain a 24-hour radio watch and have enough lifeboats for all on board. They also helped establish the International Ice Patrol, which monitors icebergs in the North Atlantic and warns ships of potential dangers.
People ask the question, what sank the Titanic? At first glance, the answer is obvious. It hit an iceberg. But that simplistic answer masks deeper and more substantive questions. How did the huge ship called unsinkable easily float in water, but then in a few hours became a sudden wreck? To understand how and why the Titanic sank, we should first understand what makes an object float and what makes an object sink.
So let's talk a little about the scientific part of the Titanic. First, let's look at what density is. Density is a measure of how heavy something is compared to its size. If an object is more dense than water, it will sink. when placed in water, and if it is less dense than water, it will float. Density is a characteristic property of a substance and doesn't depend on the amount of substance.
Why do ships sink and float? Comparing density. Any object will either float or sink in water depending on its density, how much a certain volume of it weighs. If it's more dense than water, it will usually sink. If it's less dense, it will float. It doesn't matter how big or small the object is. A gold ring will sink in the water, while a piece of plastic as big as a football field will float. The basic rule is that an object will sink if it weighs more than the exact same volume of water. Whether or not an object floats, it has more to do with density, weight. For example, big ships like the Titanic weigh tons, but typically float along because they are designed to be less dense than water around it. How are they designed to be less dense?
The Titanic was designed to be less dense because the air that is inside the ship is much less dense than water. That's what keeps it floating. As a ship is set in water, it pushes down and displaces an amount of water equal to its weight. So, the reason the Titanic sank is because the density changed when the ship hit the iceberg. That made the water in each section fill above the ship's waterline.
Did a fire sink the Titanic? There is a new theory about how the famous Titanic sank over a century ago. A journalist claimed that it wasn't simply a crash into an iceberg that caused the largest cruise liner of its time to sink. Rather, a smoldering fire broke out in the ship's cold bunker boiler rooms before it left the English port at Southampton, and weakened ship's structure so that the iceberg crash was more devastating than it would have otherwise been. Experts tend to agree that a combination of different factors led to the Titanic's voyage becoming the disaster it was. Possible factors include the ship's fast speed, a missed iceberg warning, a wrong turn, the particularly icy climate, weak shipbuilding materials, a shortage of binoculars, and a lifeboat shortage. So what conclusions can we draw from the events of April 14th, 1912, a century after the Titanic sank? First, there can be no doubt at the very start of the ship's construction, there was a problem with the materials.
Second, the steel plates of the time may have been inadequate for the task in waters of these temperatures, and the rifts were inferior quality, and when the Titanic hit the iceberg, its density changed and then sank.
Third, mistakes were made by the crew once the vessel was underway. The absence of binoculars in the crow's nest, Smith's decision to maintain a high speed despite the abundance of iceberg warnings, the radio operators' tardiness in getting crucial information to the officers, and their emphasis on passenger messages rather than operational ones, and, of course, the almost cynical lack of lifeboats.
Because of its large impact, the Titanic will never be forgotten. It changed sea safety and shipbuilding forever, correcting centuries of error and saving lives. As first international disaster, Titanic will be a